In this question, we are asked to calculate the rate of change of y with respect to x at the point pi over 4 and pi over 4. Note that here we have an implicit relation between x and y. We have square root of 2 cosine of x plus y on one side and cosine x minus cosine y on the other side. Please note that y is a function of x. Since you have left-hand side and right-hand side, you're going to take the derivative of both sides. So the derivative of square root of 2 cosine x plus y is equal to the derivative of cosine x minus the derivative of cosine y. We're going to apply chain rule here. The derivative of square root of 2 cosine x plus y is going to be negative square root of 2 sine xy times 1 plus y prime. On the other side, you have the derivative of cosine, which is negative sine. And here, plus sine y times the derivative of y. Take a look at the recall down here. The derivative of square root of 2 cosine of x plus y is equal to negative square root of 2 sine of x plus y times the derivative of x plus y. And note that y is a function of x. So the derivative of square root of 2 cosine x is equal to negative square root of 2 sine x plus y times 1 plus y prime. The derivative of x is 1. The derivative of y is y prime. Now that we took the derivative of square root of 2 cosine x plus y, which is negative square root of 2 sine x plus y times 1 plus y prime. On the right-hand side, you have negative sine x plus sine y, y prime. We're going to bring all y terms to one side, but before doing that, let us distribute this quantity inside parentheses. You get negative square root of 2 sine x plus y times 1. As you can see, it's written here, plus negative square root of 2 sine x plus y times y prime, which is written here. Very well. It's equal to negative square root of 2 sine x plus y minus square root of 2 y prime sine x plus y equals to, well, on the other side, we have negative sine x plus y prime sine y. Now bring all y primes to one side and factor out y prime. So again, the derivative is negative square root of 2 sine x plus y minus square root of 2 y prime sine x plus y equals to negative sine x plus y prime sine y. Bring this term to the other side and then move this term to the right-hand side. You can factor out y prime. Negative y prime sine y plus square root of sine x plus y is equal to square root of 2 sine x plus y minus sine x. So negative sine x stay here, and then you bring the other term to the other side. So basically your y prime is equal to, you're going to divide both sides by negative sine y plus square root of 2 sine xy. On the other side, you can multiply by negative sign, so that's how you end up with sine x minus square root of 2 sine x plus y. Now that you have your y prime, you can plug in pi over 4 and pi over 4 for x, for y, and simplify. Recall the unit circle. When you have pi over 4 or 45 degrees, sine and cosine are both of them are equal to each other, and it is square root of 2 divided by 2, or 1 over square root of 2. So you have sine of pi over 4 minus square root of 2 sine of pi over 4 plus pi over 4. Down here, you get sine of pi over 4 plus square root of 2 sine of pi over 4 plus pi over 4, which is equal to square root of 2 divided by 2 minus, you have sine of pi over 2, which is 1, multiplied by square root of 2, which is square root of 2, divided by sine of pi over 4, which is square root of 2 divided by 2, plus square root of 2. You can simplify this by simply factoring out square root of 2. If you factor out square root of 2 from numerator, from the denominator, on the numerator you're left with a half minus 1 divided by a half plus 1, which is going to be negative a third. So in summary, when I ask you to find the rate of change of y with respect to x, you're going to take the derivative of both sides. After you take the derivative of both sides, isolate y prime on one side, so you have a formula for your y prime. Then you plug in the values, simplify the algebra, and you get negative 1/3. This is the rate of change of the function at pi over 4 and pi over 4, or it is the slope of the tangent line at point pi over 4 and pi over 4.